This will be an overview of solving for a resultant vector when you have three vectors like our daily challenge that had the speaker hanging from the wire. So in this picture you see we have a speaker represented by this dot and gravity. I said 40 pounds. You have a decimal so you can calculate it with your numbers, but I'll use this round number to make it nice and easy on me. So gravity pulls straight down, and we have tension 1 and tension 2 that are holding this speaker up, and they are both at 25 degrees from this horizontal axis right here. Okay, so what I can tell you to help you along here is that you have to think about gravity is pulling this thing down. So both T1 and T2 are pulling it back up. All right? But all of T1 is not pulling it up, and all of T2 is not pulling it up. As we discussed in class, T1 has two components. It has this vertical component right here, which would be its Y component, and it has its X component. So T1 is pulling up on the speaker, and it's pulling to the right on the speaker. T2 is doing two things also. It is pulling up on the speaker, and it is pulling to the left on the speaker. So each of these forces have two components. T1 is pulling up and to the right. T2 is pulling up and to the left. That being said, it is these two vertical components, these two Y components, that are supporting this 40 pounds. Since these angles are the same, we could assume that each of these Y components is supporting half of the weight, which in our case is 40 pounds, so half of that would be 20. So what we've got is T1 in the Y dimension is supporting 20 pounds. So then we can think about T1 in the Y dimension, and we say, okay, using our trig functions, which leg of the triangle is this? Since this is the angle that we know right here, we can assume that this is the opposite side. So T1Y, which is supporting 20 pounds, is the opposite side. Thinking back to our formulas that we've established, and you can do this with your trig, or if you just know the formulas at this point, that's fine. So now we can say 20 pounds is being supported by hypotenuse times, since it's the opposite, we're going to use sine of theta. And for us, our theta is 25 degrees. So we can say 20 pounds, not 2016 seconds, is equal to the hypotenuse, which in our case, the hypotenuse of this triangle is T1 times sine of 25 degrees. And so now we can say this half of the weight of the speaker, which the vertical component of T1 is supporting, is equal to 20 pounds. And 20 pounds is equal to that full tension times the sine of the angle. And so now, as you see, we've only got one variable, which is this right here. And so then we can go to our trusty calculator, our math calculator, or science calculator, depending on how you look at it, I guess. And I can do sine of 25, and I notice on my calculator that it's in degrees. It says degrees right there. And sine of 25 is 0.42. So now I can say 20 pounds equals T1 times 0.42. When I divide by 0.42, and I divide the other side by 0.42, 0.42. I can then find that 20 pounds divided by 0.42 equals 47.62 pounds. So 47.62 pounds equals T1. And so there we've solved for the tension in one of the cables. Now, the other homework problem, I'll just give you a jump start on that since you made it this far. If you have had 3 vectors, depending on which class you're in, they have different ones, but I'll give you the same idea. If this is F1, F2, and F3. F1 has an X component and a Y component. F2, so let's go ahead and call this F1X and F1Y. So that force pulls a little bit to the right and a little bit up. F2 only has a Y component, and F3 has a Y component and an X component. Whoops, this is the Y, this is the X. Got to be careful with those X's and Y's. And so what I've asked you to do is find the resultant. And to find the resultant, you need to take the sum of the forces in the X and add them up. So for us, it's going to be F1X minus F3X, because those are the only 2 components or forces that are acting in the X dimension. We also need to find the sum of the forces in the Y. And in the Y, you see we have F1Y going up, F1Y. All of F2 is going up, so we're going to add F2. And F3Y is going down. So this is going to be a negative F3Y. And so we figure out what these components are. We add them to F2, and you have the sum of the Y. In the end, for your resultant vector, you're going to have some amount to the left or to the right, which is just sum of your forces in your X. Whatever this equals up to, that becomes the X component. And whatever your sum of your forces in the Y becomes your Y component. And then you calculate for the resultant with A squared plus B squared equals C squared. Hope that helps. Have a good weekend. See ya.